I'm Jonathan Hall. In this video, I'm going to talk about some advanced techniques for JSON handling in Go. This is material I originally prepared for a meetup where I presented a few months ago, but the recording from that day wasn't very good quality, so I decided to re-record it here. I also go into greater detail on these topics and related topics on my blog and in a book I'm writing called Data Serialization in Go. The book is available for sort of pre-purchase on LeanPub. You can see a free sample, and if you're interested, you can of course buy the book, and as new chapters are added, you get the additional information for no extra fee. Let's get started. In this video, I will talk very briefly about what JSON is. I will talk about basic usage of maps and structs in Go when dealing with JSON. I will talk about handling of inputs of unknown types. I'll give some examples of that in a moment. And handling data with unknown fields. These are based on some questions I see frequently on Stack Overflow and other places, so I hope you'll find at least some of this to be valuable. Of course, I expect most are familiar with what JSON is. It's the JavaScript object notation as defined in RFC 8259. Basically, it's a human-readable textual representation of arbitrary data. Compared to Go's type system, it's very limited, of course. It has just 5 basic types plus null. But it is used for many, many things, from configuration files to REST APIs. Uses are endless. Of course, there are many alternatives to JSON, and most, if not all, of the techniques I will describe in this video do apply to others like YAML, TOML, message pack, possibly even XML and protobuf. But JSON I like to use as a baseline because it's so common and practically everybody deals with it at some point. So just to get started, when you create JSON from a Go object, in this example a map of string to string, it's pretty straightforward. You can more or less pass any arbitrary data type from Go into the JSON.marshal function, which will then produce valid JSON. Now, one note, throughout this talk, I often skip error checking, which is not a good idea. Obviously, in production, never do that unless you have a really good reason. But for this video, to make the demonstrations a little bit shorter, I often skip error checking. Just be aware of that. So this simple example program takes a Go map of string to string with a key of foo and the value of bar and converts it to JSON, which is pretty expected, foo to bar. Of course, we often don't use just maps in Go, we use structs, and that's where JSON usually gets a little bit more interesting and easier to work with as well. So here's a really simple example. I have a person struct that contains a name, age, and description fields. And using the JSON tags, I can tell the marshaller and the unmarshaller the JSON names of the respective fields, so they don't have to match exactly. And then I also have a fourth field here called secret, and this is unexported, as you can see, because it does not begin with a capital letter. This is a common mistake that I see happening a lot. I probably see anywhere from 2 to 3, maybe 4 questions about this on Stack Overflow each week from people who are new to JSON handling in Go. So this throws a lot of people off, but let me just talk about it here. When you have an unexported field in a struct, no package outside of the field, outside of the package that defines it, can access that struct, and that includes the JSON package in the standard library, which is the reason that unexported fields are excluded when either marshalling or unmarshalling JSON in Go. So while this is often seen as a limitation or a hassle, I actually see it as often a benefit. It gives us some flexibility. We can define structs with unexported fields that don't get marshaled into JSON when that's what we want. In some cases, it's also useful when unmarshalling JSON. We can exclude some data. We'll talk about both of these in a little bit. Mainly, I just want you to be aware of this and consider it as you go forward. So now that we have our struct defined, here's just an example of it. We define a person whose name is Bob, who's 32 years old, and who has a secret. And if we marshal this, we will see that we get the expected JSON output. We get name is Bob, age is 32, and the interesting part here, of course, the secret is excluded. Now, unmarshalling can often be a little bit trickier, and that's just because it takes a little more forethought to map arbitrary JSON data to a Go struct. But here's a really simple example. We have JSON, the same JSON we saw a moment ago, being converted back into Go, and we get a map to interface, a map of string to interface. Now, you often should avoid using just a map of string or string interface when unmarshalling JSON. And the reason is because those types are just cumbersome to work with. Of course, they're necessary sometimes, but whenever it's possible and when it makes sense, you should use a struct instead, a struct with defined data types and a defined structure. So here's an example of that. Using the same person struct we had a moment ago, this time I'm converting JSON into a Go struct. So here we have our sample JSON input, which is, as before, name Bob, age 32, and it contains a secret. Now when we execute this code, as we might expect, we get a Go struct with name is Bob, age is 32, and as described a moment ago, secret is blank, even though it's included in the JSON because it's unexported. The unmarshaller cannot access that and it's left alone. So structs are nice and maps are useful, but what happens when you don't even know the data type before you unmarshal it? Let's talk about some examples of that. One common example that I've dealt with many times is when you get either a number or a string representing a number. Some APIs are very inconsistent. They may return one or the other, depending on the phase of the moon. Maybe it changes between software versions. Maybe it depends on exactly which options you send to the API. Another common pattern I see is an API that returns either an object or an array of objects. So rather than returning an array with a single object, if there's only one, it just returns that object alone. This is something I've seen fairly commonly in more dynamically typed languages like JavaScript or Perl or Python, where that's simple, but it's a little more complicated in Go, but I'll talk about how to work around that. And then the other case I'll talk about is cases where you get completely different object types. So maybe an API that returns one type of object for success and a different type of object for failure. I'll talk about that and some more details there. So let's start with this literal number or literal string option. So this is an example of something I actually dealt with not long ago. We had an API that was returning a literal number, and then I guess through a change and upgrade in the service, it started returning a string instead, just a quoted number, and that broke our API. So how can you deal with both without having to change your code all the time? So in this example, I've created a custom type called int or string. Of course, please use more descriptive names in your own code, but for the example, it's fine. And then on that type, I've defined a custom unmarshaller, which you do by defining a function called unmarshal.json. And then inside that that function, I simply unmarshal to a number, to an integer called v, and then I assign that integer to the receiver, which is called I. Now the magical part here is that I remove any leading or trailing quote marks before doing that unmarshal. And in a simple example like this, that's sufficient. Supposing I receive a string, the quoted string quote 1, 2, 3 end quote, for example. By removing those quote marks, I'm left with just 1, 2, 3, and I can unmarshal it as an integer normally. And if I get just an integer that's just 1, 2, 3 without quote marks, then this trim does nothing, and I just still unmarshal 1, 2, 3. Now supposing I received a string that was not a number. Suppose somebody sent quote hello world end quote. Then I would remove the quotes and try to unmarshal it to this integer. That would produce an error, and I would return that error. So let's watch this in action. I've created a JSON input here that contains an array of 2 elements. The first element is a literal number. The second is a quoted number. Let's see what happens. So now our Go result is a slice of int or string. The first is a value of 1, 2, 3. The second a value of 3, 2, 1. So let's talk about the next example, this time either a single value or an array of values. So this is common in some APIs. Maybe you're querying a database or something like that, and if you get a single result, you get one object. If you get multiple results, you get an array of objects. Now, to simplify this example, I'm going to use strings rather than objects, but the principles are the same. And of course, you can update the code to use objects if that's what you need. So in my example, I have a custom type called slice or string. Underlying value is of type slice of string. And then my custom unmarshal JSON function. So the first thing this function does is it checks to see if the first character of my input data is a quote mark. If it is, I know I'm dealing with a string, and I can act accordingly. So if I have a string, I just unmarshal to a temporary variable called v that is of type string, and then I set my receiver to a slice that has a single value of that string, and I return any error I receive. If the first character is not a string, then presumably I have an array, in which case I have a temporary slice variable. I unmarshal to that, and then I set the receiver to that value. And once again, if I receive an error, I return that error. So if I were to receive an object or a number or something other than a string or an array, then this would behave accordingly. So let's look at an example. My input to test is an array of 2 elements. The first element is just a string, and the second is an array of 2 strings. As expected, my go result is a slice or string type with a single element for the first input and 2 elements for the second input. What happens when you don't know the data type? So let's use an example of an API that returns one type of object for success and another type for failure. And for the sake of argument, we'll assume you cannot determine which is which based on, say, the HTTP response code. You only know by reading the JSON result. So what I've done here is I've created a success type and an error type, so my goal, of course, is then to unmarshal success objects into success and error objects into error. So with these 2 types defined, then I create a third type that embeds both of these. So this response is sort of a generic wrapper container, if you will, a wrapper type that embeds both success and error. Now, in this case, I don't actually need to create a custom unmarshal function. And the reason for that is that the success and error structs have no common fields. So there's no ambiguity when the JSON unmarshaler tries to unmarshal data into the embedded structs. So let's look at an example. Here our input is an array of 2 values. The first is a success object. The second is a failure object. So we can see here that our result for the success case contains a success object with populated values, and then an empty error object. You can see both error and reason are empty strings. And then for the error case, we have an empty response, and the error is populated. But what happens when we have conflicting or overlapping fields? Let's look at an example. So in this example, our API returns a status key for both success and failure. So we update our success and error types to include status. You can see that that's duplicated between success and error. But now it's not sufficient to just embed them because the JSON unmarshaler won't know where the status field goes. So we have to now create our custom unmarshal function. So the first thing this function does is it just tries to unmarshal into success. Now, of course, if it returns an error, then we return that error as well. But it's not enough to check for an error. We have to also check the value of status, because supposing we get an error value, it will still successfully unmarshal. It just won't have the error field reason here. This will just be blank. So after we've unmarshaled to success, we check the success, the status value. If it's okay, as we expect for success, then we're done. We return nil. If we get any other value, we assume it's an error. So then we set the response.success value to a 0 value, and then we unmarshal to error. Let's look at our demonstration. Once again, we have a success case and a failure case. Both of them have status with different values. And as before, you can see that in the success case, we have a success object, status is okay, and the other values are set, and error is empty. For the error case, we have an empty success value, and then the error field is set with its own status. But the response type I've been using here is maybe a little bit cumbersome. You have to always check whether it's the success or the error value within that response that is populated. Maybe you don't want to have two objects. You want to have just a single one, and then deal with that one. So let's talk about a way to use a different container type to solve that problem. So here I'm still using the same success and error structs as before. I'm only changing the response struct. So rather than having both success and error embedded, I've just created this result field that's an empty interface. Now let's look at the custom unmarshal function. So here I create a value of type success, again, the one I defined a moment ago. I unmarshal to that, same as before, and also same as before, I check to see if the status is okay. If it is, then I set the result to success and return nil. Then if our status is anything other than okay, we continue. We define a value called fail, which is of type error. We unmarshal to that, and then we set the result to fail and then return nil. Let's look at an example. So we have the same input as before, but now our output has only one result value for each input rather than one populated and one empty. So for success, you see that we have the success case, and for error, we have the error case. Let's go a little bit further with container options. So in this example, I'm defining my unmarshaled JSON function on a slice of the empty interface rather than on each individual object. The way this works is I start by unmarshaling the JSON into a slice of JSON raw message. As we can see from the Go doc for the JSON package, JSON raw message is just a byte slice, but it has a custom marshal and unmarshaled method that simply pass the data through unaltered. And this is useful, as you'll see in just a moment, where all I care about right now is chopping my JSON into individual elements rather than parsing the entire thing, that I can process each element one at a time. So let's do that here. So I unmarshal into my slice of JSON raw message. Then I define a success and a fail value, similar to before. Then I pre-allocate a result slice of the same length as my input, and then I loop through my input. For each value in my raw input slice, I unmarshal to the success struct. If the status value is okay, then I assign that success value to the result, and I continue. If it's anything other than okay, then I unmarshal to fail, and I set that value to the result. At the end, I set the result to the receiver, and I return nil. So you can see it's essentially the same logic as before, but in a loop this time. Let's look at the example. Our output is pretty much exactly what we would expect, almost identical to before. For the success case, we have one success object. For the failure case, we have one error object. Of course, it can get much more confusing. Let's suppose rather than just success or failure, we have 3 or maybe 4 or 1,000 different object types. For my example, I have 3. I have a person, an animal, or an address. And other than the type field, everything else about the object is arbitrary or completely different. So I've defined my 3 core types: person, animal, and address. And then I create my container, my responses, which is a slice of empty interface. My unmarshaled JSON method goes on that container type, the responses. And same as before, I create a temporary slice of JSON raw message. I unmarshal to that. Now here I've created a variable called header, which is of type struct, this anonymous struct, that just contains a single field called type. And then as before, I define my result slice, pre-allocate it to the same length as my input. Now my loop, of course, is a little more complicated now. For each case in my input slice of JSON raw message, I unmarshal first to this header, and then I check the value of that header, the type field in that header. If the type is person, then I unmarshal to person. If it's animal, I unmarshal to animal. If it's address, I unmarshal to address. And in each case, I assign that value to that particular index in the result. And finally, as before, I assign the result to the receiver and I return nil. Let's look at an example. So our input here has 3 different objects of 3 different types, and the output result is a slice of empty interface. The first element is of type person, the second animal, and the third address, as you would expect. Now, while this last example works fairly well, and it's perfectly good for small bits of JSON, it's not particularly efficient. And the reason for that is because it reads the entire JSON array into memory when it parses it to the slice of JSON.raw message. And then it goes through each one of those elements individually and parses the final result. So we have a completely extraneous copy of the entire array in memory that we don't need. That's especially wasteful, of course, if you get an error early on in processing. So you've read this entire thing into memory, you get an error, and then you throw the whole thing away. But even for a success case, it would be much more efficient if we could just read each one individually rather than using up all that memory. So let's look at a way to accomplish that. So for this example, I'm using the exact same configuration as before. I still have a person, animal, and address types, and I still have a responses type that is a slice of the empty interface. The only thing I'm changing here is my implementation of unmarshaled JSON. The functionality should be the same, it's just hopefully more efficient now. So my new implementation of unmarshaled JSON takes advantage of the JSON decoder, which takes an IO reader as input, and then the decoder allows you to use this tokenizer interface to interact with it. So I define my decoder here, and then the decoder just reads the input using the bytes.newReader. The first thing I want to do is consume the first token, which I'm assuming for this example is correctly an opening square brace. Of course, to be more robust, I would actually validate that's what it is and return an error if it's not. I trust that you can add that to your own implementation. Then I create my result output. Now, in this case, I don't know the size of my output, so I can't pre-allocate it. So I just set it to 0 length. And then once again, I create my variable called header, which is of this anonymous struct type, which contains just the type field, same as before. Now my loop is slightly different. Now I still use this JSON raw message, but I just have a single instance, as you can see, rather than an entire slice. And that's because I need to unmarshal the value twice still. So I start by decoding the next symbol from the decoder, the tokenizer, into this raw value. Then I decode that raw value into the header. Once I've done that, then I have my header.type that I can use to see where to unmarshal the rest. If the type is person, I unmarshal to person. If it's animal, I unmarshal to animal. If it's address, I unmarshal to address. Essentially the same as before. Now, this time, rather than assigning to a particular index of the result, I just append, since I don't know how many results I have. At the end, as before, I assign the result to the receiver and I return a nil error. Now, our example should be identical. We have the same inputs, we expect the same outputs, and indeed we see the same outputs. It's just a more efficient implementation. Now let's talk about something that's even more interesting, at least for me. Supposing you have a data structure that has some known fields that would map well to a struct, and some unknown fields that would require a map, say of string to string or string to interface. But you don't want to do everything as a map. Let's talk about a way to do a hybrid approach. So here's our example input data. We have, in this case, 2 fields that are the same across all objects, the underscore ID and the type. Everything else is arbitrary, and we don't have any way to know what it is. It might be that these fields vary based on the type, or they might be completely arbitrary. And so we'd like to access the ID and type through struct fields rather than using a map. Everything else must be in a map because we don't know what it is. So here's our target type. I've created a type called item. Represents some generic thing that has an ID and a type and arbitrary data. Let's look at the custom unmarshal function I've created. So the first thing I do in this function is I define a variable called x, which is of this anonymous struct type. This anonymous struct embeds the item type, which I defined on the previous page here, and it also adds this field called unmarshaled JSON. Now the only reason this exists is to overshadow the method, the unmarshaled JSON method on the item type. If I don't do that, then on this next line, when I call JSON unmarshal on x, it will find that item has the unmarshaled JSON method, which is actually defined right here, which will create an infinite loop and cause the program to crash. So with that in mind, I do call JSON unmarshal of the raw data into x. And then I call, down here, I unmarshal the data a second time, this time into a map of string to interface. Then I delete the two fields that were previously handled up here, the ones defined in item, ID, and type. I assign the item here to my receiver, and then I set my data, my arbitrary data. So let's look at an example. Here are our three example input objects from the beginning. And when we execute, we see that we get a go slice of type item. And each one, the first one has an ID of Bob, type of user, and then the arbitrary data, the name. Second one has an ID of meetup, type website, and arbitrary data with the URL. And again, the third ID of soup, type of recipe, and arbitrary data. Of course, doing this is most useful if you can reverse the process. So let's talk about that. So now instead of creating an unmarshaled JSON method, we're creating a marshaled JSON method. It's working on the same data type, the same item struct. The first thing I do is I marshal the data. So this is the arbitrary map data to a value called data. Then again, I use an anonymous struct type for the marshaling. I embed item inside of it, and same as before, I create this empty struct field called marshal JSON to avoid the infinite loop. In addition, I added this JSON tag. If I don't do this, then the output will contain something called marshal JSON with no fields, which I don't want. Then I marshal this temp value into raw data called obj. So at this point, both data and obj should be completely valid JSON objects, each with a subset of the data we're concerned with. Data contains the arbitrary data values, and obj contains the ID and type fields. So to combine those, what I do is I replace the final character of obj, which should be a curly brace, a closed curly brace, with a comma. And then I append all except the first character of data to that and return that. So here we have our input data is, this time it's Go objects, but they're essentially the same data we had before. We have Bob, meetup, and soup. And let's see what the JSON output looks like. In the first case, we have an object with three fields, ID, type, and name, as expected. The second one, ID, type, URL, and the third one, ID, type, and ingredients. Thank you for watching. I hope you found this information valuable. If you have any questions, please reach out to me either in the comments or on my blog. I'd love to hear from you. And don't forget to like and subscribe if you found this valuable.